welcome again. Let's continue with the second session of the profiles and profile interoperability training. First, look at the agenda. We will have a recap of the first session. We will continue with the interoperable profile format. After looking at the profile format, we will look at the EUICC, what is the expected EUICC behavior according to the Simlian standard. We will look at the EUICC test specification to see what is tested. We will look at the profile classes which are used in the GSMA RSP consumer standard. We will look at the interoperability aspects of a profile. And finally, we will have a summary also today. So let's start with a short recap what we have learned in the first session. We have learned what is a profile. The profile is basically a data file which contains operator data, application, and potentially third-party applications. We also learned why there was a need to standardize the EUICC profile format. We learned how the EUICC file system looks like. We learned how do we create the file system using templates, created by default templates and not created by default templates. We learned how to create the file system using the generic file management. And finally, we looked at the content and the parameters which are used in the p-pin codes and the p-pack codes. So now, continuing with the interoperable profile format. Today, we will look at the remaining profile elements, which are the P security domain, the P application, the P RFM, and the PEN. Let's start with the security domains. So first, an intro about what are the security domains. Security domains are secure containers which separates the EUICC applications belonging to different business entities from each other. There is one MNO SD and optionally other SDs in the MNO profile. And the third-party applications, for example, with payment application, CTZ, etc., are loaded into the security domains. And these are separated securely from each other. The security domain is also enabling the owner of the application to access its application remotely. So, take a look at the PE security domain. The security domains, as you might guess, are created by using the PE security domain. The first security domain in the profile which is created is the MNOSD. The MNOSD is owned by the operator. It provides a secure channel to the operator's OTA platform, and it is used to manage the content of a profile once the profile is enabled. For example, delete files, load new applications, and so on. Look at the main parts of the PE security domain. There are three main parts. The instance object. In this part, the instance parameters of the security domain are provided. For example, AIDs, privileges, lifecycle state. The next one is the key list object. In this part, the personalized keys are provided. And the third one is the SD perso data object. The personalization of the security domain, for example, setting issuer identification number, card identification number, and the OTA HTTPS settings can be provided in this part. Let's look at the example. We see here the first main part, which is the instance object. And now first look at the AIDs. There are three AIDs: application load package AID, which is the identifier of the package which is loaded on the UICC, then the class AID, and finally the instance AID, which is the identifier of the instance. And the security domain can be selected with the instance AID. Besides the AID, the application privileges are provided in the instance object. Then the lifecycle state, which indicates in which lifecycle state the SD is. Then the application specific parameters C9, which indicates which secure channel protocols are supported and if extradition is supported. And finally, the UICC toolkit application specific parameters field, which indicates the minimum security level, the TAR value, and so on, the parameters which are used for remote communication. So in this example, in the instance object, these fields are listed. It's possible to use other fields as well. Look at the key list object. It contains the personalized keys. The first one which we see here is the C-enc and R-enc key, and this is indicated by the key usage qualifier, and this key can be used to establish secure channel with key usage identifier 38. Then the key access parameter, which indicates if this key can be accessed or not. Then the key identifier and the key version number. And then the key components where we indicate the key type. For example, here this is an AES key and the key data, which contains the value of the key. The second key in this example, it is with key usage qualifier 34, which indicates that this key is used for MAC computation. And the third key is with key usage qualifier C8, which indicates that this key is used for data encryption and decryption. Finally, in this example, the P is security domain, the SD person data, which was third main part. This is here, you can see the IIN issuer identification number and the CIN card identification number are given here. Let's take a look at a few coding rules of the P security domain. Each key to be personalized must be listed only once. It means there shall be only one key with the same key identifier and key version number. For the MNOSD instance, no value shall be provided for the extradite security domain AID parameter. This is because the MNOSD is associated with itself and it is not subject to extradition. For the ECC keys, key components shall be defined using key object, and the ECC curve parameters shall be defined using the SD person data. After the security domain, let's take a look at the PE application. The P application is used for loading and installing applications like payment, mobile ticketing application, just to give a few examples. Each application is associated to a security domain. So, P application shall be used after the security domain to which the application instance is associated to. The main parts. There are also three main parts for the P application. First one is the load block. It contains load package related parameters, for example, load package AID or memory handling parameters, and the load package itself, which is the code of the application. For example, for a Java card application, code of the cap file. Then the instance list. It contains parameters used to instantiate and personalize the application. For example, instance AID, application privileges, system specific parameters, or application parameters. Finally, process data, which is used to personalize the applet instances or some specific behavior. And now let's take a look at the example with the concrete coding. In the load block, we can see the load package AID and the load block object, which is the code of the applet. Here is just not the full one, just you can see here there are dots, so that's much longer what we can see here code. Then in the instance list, there are the three AIDs: application load package AID, which is the AID of the package from which the application instance is created, class AID, and the instance AID, which is used to select the application. Then we have the extradite security domain AID, and this AID indicates which SD this application belongs to. Then application privileges, application specific parameters C9, which indicates secure channel protocols which are supported, and again if extradition is supported. And under the application parameters in this example, the UICC toolkit application specific parameters field, which again similar to the EESD coding indicates minimum security level, DAR value, and so on, parameters which are used for remote communication. And finally, in the process data, where we can give some personalized specific behavior, for example, to a specific command APDU, which response APDU do we expect from the application. Some coding rules for the P application. In case no value for the optional parameter extradite security domain AID is provided, the instance will be associated to the MNO SD by default. An application or security domain shall only be associated to a security domain in lifecycle state personalized. That's very important. And then after the PE application, we will look at now the PE RFM, which is PE for the remote file management. This PE is used to set up parameters for the remote file management, so it sets controls how the files can be accessed or changed remotely. It shall be installed after the creation of the SD it belongs to, or after the ADF if it is associated also to an ADF. It contains the RFM parameters based on the ETSI technical specification 102226, which defines the tar list, minimum security level, UICC access domain, and ADF access domain. An example, we can see here the TER list, which contains the identifiers used to remotely select this application. There can be one or more. It indicates the minimum security level, which specifies the minimum security level which is needed to communicate with this application. So the APDUs needs to have minimum this security level which are sent to this application. Then the UICC access domain, which specifies the access rights of this application to the UICC file 3, the UICC admin access domain, which specifies the administrative access rights of this application to the UICC file 3, and optionally, under the ADF RFM access, there can be these parameters: the ADF AID, which is the identifier of the ADF this application has access to, the ADF access domain, which specifies the access rights of this application to the specific ADF, and the ADF admin access domain, which specifies the administrative access rights of this application to the specific ADF. In case the PRFM contains no ADF RFM access, then it cannot have access to the ADF, only those parts of the UICC file 3 which are not within an ADF. Let's take a look at the access domain coding. The access domain value within the PRFM sets the access right of the remote file management application over the file system or a specific application. The value null indicates full access to the file system, which means all actions can be performed on a file except the ones with never access condition. FF indicates no access to the file system, which means no action can be performed on any file. And finally, when there are concrete values 0, 2, and some concrete values, then the XX YYZZ bytes sets the access rights on pin level. It means the RFM application can perform those actions like read, update, and so on, which are protected with this specific pin. There are two more PEs which we take a look. One is the PE non-standard. This PE is used to send the proprietary content or send the content which is standardized in the specification after the creation of the UICC. This element may be provided in any position after the profile header. An example of the PE non-standard we can see here. This is a very small one here. It has a specific issuer ID and it has some content. And finally, the PE end, which PE is used to indicate the end of the profile package to the UICC. And this is just this small. So now we went through all the profile elements, and let's take a short break, take a quiz now. Same as we did for session 1, I will show you the statement or question, possible answers, give you some time to think, and then we will see the correct answers. So the first statement: a security domain has cryptographic keys. Is it true or false? And the correct answer is true. Second statement: every application is associated to a security domain. Is it true or false? It's true again, because every application needs to be associated to a security domain. Which AID is used to select an application? Load package AID, or class AID, or instance AID? And the correct answer is the instance AID. What UICC access domain 00 value means? A. The application has no remote access right. The RFM application has no remote access right. the RFM application has full remote access right, or the RFM application has access right only for pin 0 protected files. Which is the correct answer? The correct answer is B. The application has full remote access right. After we looked at how the profile itself looks like, profile elements, coding, and so on, now let's take a look at the EUICC side. What is expected from the EUICC when it receives a profile? It is expected that the EUICC correctly interprets a correctly formatted profile. So, in case it receives a correctly formatted profile, then it needs to create the file system, security domain, and so on based on the profile content. In case some content of the profile is not supported by the EUICC, it is expected, it is mandated, that the EUICC reports it, and based on the unsupported content, it either aborts or continues the installation. It depends if the unsupported content is mandatory or not. But it's very important that this is not expected, not mandated, that the EUICC would detect if a profile is incorrectly formatted. Now, let's see what are the possible EUICC responses. How the EUICC response structure looks like. The EUICC reports back the status of the installation to the SMDP server in an EUICC response object. The EUICC response may contain several status messages, P status objects, corresponding to the profile elements which are being processed. In case there is an error which leads to abortion, EUICC response containing the profile installation aborted shall be sent immediately. And in case of a successful installation, EUICC response ending with a PE status containing the OK status code shall be sent. And see three examples. The first example is when the installation is aborted due to a PE not supported error. So the PE which is received by the EUICC is not supported by the EUICC. What we can see here in the EUICC response object, there is a PE status, and within the PE status there is a status code which is indicating that the error is the PE not supported, and the identification, which is the identification of the PE causing this error. And on top of this, the EUICC response shall contain the profile installation aborted null, which means that the profile installation is aborted. Second example. This is a successful installation and there is nothing reported, so everything went well. Here in the EUICC response object within the PE status, there is an OK status code, and that's all. And there is a third example when the installation went through, so the installation is successful, but there are two warnings. And the two warnings are, the first one here is for the PE15, a feature not supported warning, which indicates that within this profile element, there is some feature which is not supported by the EUICC. But this profile element or this feature is not mandated. And here is another warning for the PE with identification 20, which is PE not supported. So again, this PE is not mandated, but there is a warning reported back to the SMDP that this PE was not installed, but in general, the installation went through and the status code OK is sent. So far, we've been talking about the technical specification. The technical specification indicated how the profile shall look like and also indicated how the EUICC shall behave. Let's now take a look at the test specification and let's see what is tested by the test specification. The EUICC behavior is tested based on the TCA EUICC profile package interoperable format test specification version 2.x currently, which is available here. And this is very important that the scope of this test specification is to verify that the profile interpreter component on the EUICC is working correctly. So the test specification tests the EUICC behavior. The test specification does not test the profile format itself. Most test cases are used to check if the EUICC is correctly interpreting the profile and capable to create the file system, security domains, application, and so on accordingly. In addition, there are some test cases which tests error or warning scenarios where the EUICC is expected to report an error or warning. And let's take a look at 4 examples. First example test case. The test case name is installing using files by template, and the scope is to install a profile with file system templates and check if the files on the EUICC are created in accordance to the profile content. So how do we test? We have a test profile. Within the test profile, I just indicated which are those parts related to the file system. So EF, CD, Telecom, USIM, OpUSIM. And we take this test profile and install this test profile to the EUICC. This is what we can see in the first step. And in the second step, we expect EUICC response with the status OK, without profile installation aborted tag, and also there is no PE identification check because everything went well. So how do we check that everything went well? How do we check that the file system is correctly installed? It's basically that we select the files in the F and verify the FCP. Also, we read the files in the MF, verify that the content is the same as defined in the PEMF by template 1, which was part of the profile package we sent to the EUICC. And we do the same for the CD, for the Telecom, for the ADF USIM, for the OpUSIM. Example test case 2. So we want to check that the mandatory elements in a PE security domain are correctly installed. So we install a profile with PSD and check if the security domain is created with the parameters defined in the PSD. The test profile contains PE security domain MNOSD1. This is what we will check. So again, we send this test profile to the EUICC. The response from the EUICC in step 2 is OK status and no PE identification object. And how do we verify that the security domain is created with those parameters which are sent in the profile? Is we send the get status command to the MNOSD and we check that the get status command responds with those parameters which were on the profile. So the AID of the MNOSD needs to be the same as the instance AID in the profile. The lifecycle state needs to be the same as the lifecycle state in the profile. Privileges, SCP register data. Finally, status for 9000. Let's take a look at an error test case. How do we check a specified error behavior? So, the scope of the test case is to install a profile with PESD in selectable lifecycle state and then check if the installation is aborted when we are trying to load an application PE. So here we have the test profile. The security domain SSD2 is not in personalized but in selectable lifecycle state, and we try to install the PE application 3 under this security domain. So what is expected to happen? We send the profile package, and in step 2 we see that the EUICC shell responds with P status 6, which is invalid parameter, and the identification of PE application 3. And the last EUICC response shall contain profile installation aborted object. And finally, a fourth example test case. This is a warning scenario. Warning when installing using files by template with paired TLV files in non-mandatory PE when the EUICC does not support bare TLV. So the scope is to check if a warning is reported and the installation continues. Because the EUICC does not support this file type, but this file is within a non-mandatory PE. So how do we check this warning behavior? So here we have the test profile. Within the PE telecom by template, we have 3 bare TLV files, but this PE is not mandated. And we send this PE to the EUICC. And in step 2, we expect that the EUICC responds with P status 10, which is feature not supported, and the identification of the P telecom by template 3. Also, the EUICC response shall contain no profile installation aborted object, so the installation shall continue. And what is installed? The MF, the CD, telecom, and the ADF using templates, because these were part of the profile. But what is also important is that in the DF telecom, look at step 8, in the DF telecom, the EF ICE graphics, the EFMML, and the EFMMDF shall not be present. These are the files which are bare TLV type of files. Where the TCA EUICC test specifications are referenced. GSMA references the EUICC profile package interoperable format test specification in the GSMA SGP23 consumer EUICC test specification and in GSMA SGP11 M2M test specification. And also the EUICC test specification is part of the Global Platform EUICC Consumer Device Compliance Program and the Global Platform M2M Compliance Program. After we took a look at the TCA specification, which defines general profile structure, now let's take a look at how the specification is used in the GSMA RSP standard and specific aspects that the profile classes which are defined in GSMA. As we know, the TCA EUICC profile package interoperable format technical specification defines a general interoperable profile structure. This structure is used in the GSMA RSP specifications, but on top of this, in GSMA, RSP consumer device specification defines 3 specific profile classes: operational profiles, provisioning profiles, and test profiles. The operational profiles. operational profile can be seen as the normal profile. Using operator credentials, it can be used to authenticate to an operator's mobile network. Profile indicated to the LPA as operational shall be visible to the end user. It means that the end user can manage an operational profile. It can delete, disable, and so on. The provisioning profile. Provisioning profiles are used for profile download, profile maintenance functions only. Provisioning profile and their associated profile metadata shall not be visible to the end user, and provisioning profiles shall not be selectable or deletable by an end user action. Finally, the test profile. It is not mandatory for the UICC to support test profiles. The test profile shall have the same format and structure as any other profile. If a test profile is installed on the UICC, it is visible and usable only when the device is in device test mode, if the device supports it. In a test profile, it's very important that there are specific keys for the network authentication to ensure that the test profile cannot be used to access to the network. So it cannot be used as an operational profile. After we looked at the profile classes defined by GSMA RSP consumer standard, let's take a look at the interoperability aspects. What we can say that the profile which complies to the TCA or Similarity standard is interoperable. What does it mean? It means that this profile can be installed on a TCA compliant UICC. We know that there is a compliance program for the UICC. The interoperability between a profile and the TCA compliant UICC is expected only, however, for a correctly formatted profile. In case of an incorrectly formatted profile, UICC behavior is undefined. It may lead to issues on the field, which has been seen. So, interoperability issues. What has been seen is, for example, the profile has not been installed, or the profile has been installed but with a different content on the UICC compared to what it was defined in the profile. As I mentioned, there is a compliance program for the UICC, but on the other side, there is no official verification process for the profile. It is needed to ensure the interoperability that the profile is correctly formatted. So that's why Comprion offers solutions to verify that the profile content is based and compliant to the TCA specification. This is by the UICC Profile Manager tool. Also, compliance offers solutions to test that the profile download and the content verification on dedicated UICCs are successful, so that the profile is downloaded with the correct content as expected. So we have reached to the end of the second session, and let me give you a summary about the complete training, what we have learned and what we can take away with ourselves. To enable remote UICC provisioning, the structure and the coding of the profile had to be standardized. The TCA UICC profile technical specification defines the format of the profile on one side and the EYCC behavior on the other side. The standardized structure ensures that profile can be installed on an EYCC which is compliant to the TCA specification. Global Platform EYCC M2M and consumer compliance programs certify the EYCCs that these are compliant to the TCA specification. But interoperability, which is key for the EYCC ecosystem, is expected only if also the profile is formatted correctly. I would like to highlight this. We have reached the end of session 2, also the end of RSP Advanced 3 training about profiles and profile interoperability. I would like to thank you very much for your attention, and I hope you enjoyed this training. Thank you. Goodbye.